Hello, my name is Ege Yıldırım and today I'm going to be teaching you binomial theorem for the maths year project for grade 10. So first of all, you need to know some terminology here, and those are binomial theorem, which is actually the name of the topic, term, coefficient, combination, and degree. So let's start with how to find the coefficients and powers. Well, this is a binomial expression, but it's too hard to be understood, and I'll make it easier by an example. Well, I'll use combination, as you can see there, and I put the degree on the top of this combination. And for my initial term, I'll use 0 at the bottom part of the combination. And then I'll put my x here, the first term of this whole term, and I put the degree on the top of it. Then a plus, as you can see, there's a plus, and again a combination, the degree, as you can see, and now I put 1, so it's 3 to the 1, and I put x again, but now I just take 1, and then I put my second term of this whole term, and I put this 1 to the top of it. And then again a plus. I use combination again, 3 to the 2. I put my x here, take 1 again, I put my 2 here, and I put this, the bottom part of the combination, and put it to the top. Again a plus, and again a combination, but now it's n to the n, so 3 to the 3 in this case. I don't actually put my x here because the degree of it will be 0. I put the second term of this whole term, and I put the degree on the top of it. So now it is 1 times, because n to 0 is 1 times x cubed plus 3, because n to 1 is n, x squared, and then times 2, plus 3 to the 2 is actually equals to 3 to the 1, because the addition of them are 3. So I put 3 again, times x times 4, plus 3 to the 3 is actually equals to 3 to the 0, and it's 1, times x to the 0, x power 0, times 8. Now it's actually 1, so I don't need that. It is x cubed times 6x squared times 12x plus 8. Well, this theorem has a proof, and it is actually like a proof that it's the short way and it works. So I'll first do the long way. I'm going to multiplicate these two terms, but know that this isn't whole term. I'll go like this, 2x times 2x, and plus 2x times 2y plus 2x times 2y plus 2y times 2y, and it is 4x squared plus 4xy plus 4xy plus 4y squared, and this is actually 8xy. And this is a long way and it takes a lot of time actually, so I will do the shorter way, which is actually binomial theorem. I will put the degree and 0 for my first term. Don't forget we write 0, but it is the first term. 2x to the power of 2 plus 2 to the 1, 2x to the power of 1, 2y to the power of 1, plus 2 to the 2, 2y to the power of 2. So this is 1 times 4x squared, and I don't need that, times this is 2 and this is 2 again, and I have x here and I have y here, and this is 8xy plus this is again 1 times this, and this will be 4y squared, and I get the same answer with an easier way. And we have a Pascal's triangle here, and this is a relationship between the binomial theorem, actually with combinations. So to find combinations easily, I'll count by starting with 0, 0, 1, 2, 3, 4, and 5. And what do I need here? 4 to the 2. I go to 4, and again I count with starting 0, 0, 0, 1, 2, and then it's 6 plus I go to 5 because I'm now looking for it. 0, 1, 2, 3, 4. And it's 11. Well, there are some important things to know, and those are x plus y to the power of n, then n plus 1 is the terms in the binomial expression. In each term, the sum of the degrees give n. To find the sum of the coefficients, give 1 to the x and y. To find the constant term, give 0 to the x and y. Now, here are some examples. X squared plus 2y to the power of 5. How many terms in this expression? So I actually don't need that because I actually know that n plus 1 will be the number of terms, and it is actually 5 plus 1 and it's 6. And the second example, x plus 2y to the power of 2n. If the middle term is a times x cubed times y cubed, then what is a plus n? So I will actually find n first, and to find n I add the degrees up, and this will give 2n equals to 0 and n is 3. And then I can easily say that it's 6 to the 3. This is the middle term actually, and x to the power of 3 times 2y to the power of 3. So I actually don't need those x cubes, and I don't actually need those y cubes, but I need 2 cubes. Now it is 6 to the 3 times 8, and I can say that 6 times 5 times 4 divided by 3 times 2 times 1, and this is 20, and 20 times 8 is 160, and I add 3 so that I get 163. What is the sum of the coefficients in this binomial expressions? Well, to find the sum of the coefficients, I give 1 to each x and y. 1 plus 2 to the power of 9, and it is 3 to the power of 9. And there's an interesting fact. Binomial theorem is found by Ömer Hayyam, who was a Persian poet, writer, and mathematician. And there are a couple of questions. First of all, if one of the terms is k times x times y to the power of n, what is n in this binomial expression? Well, if I see x is actually x to the power of 1, I can easily say that 4 minus 1 is 3, and then it is equals to n. The other question, if this binomial expression gives me x squared plus y to the power of 6, what is the power of x on the second term of this binomial expression? So if I look for the second term, I can say the combination will be 6 to the power of 6 to the 1 and times x squared. This will go to the top of y 1, and this will be 5. So power of x is asked, so it will be 10. The other question, 3x plus 2y to the power of 6. In this binomial expression, how many terms are odd degree for x and y? Well, if I look for odd degree ones, then it will give 6, obviously, and one plus 5 will give 6, 3 plus 3 will give 6, and 5 plus 1 will give 6. So there are 3 terms. And the other question, x plus 2y to the power of 7. If a term is a times x to the power of n times y squared, what is a? So if I look for n, I can say that it is a times x to the power of 5 times y squared. But actually, if I look to the binomial expression, this is times 2 to the power of 2 because of this term in this whole term. And if it's the third term, this will be 7 to the 2, 7 times 6 divided by 2 will give 21. 21 times 4 times x to the power of 5 times y to the power of 2. I am asked to find a, so I can cancel those. This is actually 84, and this is the answer. Thank you for watching me.